Okay, so today we will start our next lecture about particle physics, in which we will discuss chapter number 2 of Griffiths, which is about, we will discuss about ranges of forces. There are four types of forces range. First is electromagnetic force, the second one is weak force, the third one is strong force, and the fourth one, is the gravitational force. So these are the four basic forces. Okay, so today we will discuss about those forces, and we will discuss about their ranges. Okay, so first of all, we will discuss about electromagnetic force. So what is basically electromagnetic force? In which electron emits and absorbs photon. Either electron emits and absorbs photons, which is gamma. Gamma is basically the photons, which happens in only short range of interval is given by, because electromagnetic force have short range. Due to the strong interaction, it has short range. So electromagnetic force either emits if electron emits or absorbs photon. If electron emits or absorbs some photon gamma, you will see there is some electromagnetic force, and their time interval should be very short. Okay, so to compare this, we will start with an example of Heisenberg uncertainty principle. Heisenberg uncertainty principle is basically what this is: the delta E delta T, which is equals to h cut. If you move this E to the other side, this becomes like this. Now you just have to put the value of E, which is by Einstein's relation, E equals to mc square. So put the value here, mc square. Because we have to find the range of forces, we know what is basically range. Range is the distance basically covered. So in classical, we know that distance equals to s equals to vt. So in particle physics, so this is our range, means distance equals to vt. We will take s compared to speed of light, so this is equals to ct. So this is the formula of range. If you want to find the range of forces, you will just use ct. C is the speed of light and time is the time interval which that force takes. So you just have to put the value of time interval, which you upside and just find that, which is h cut by mc square. So h cut by mc square and c. So this is your value of rest. This is the value for range of forces. So here we will discuss about electromagnetic force. So electromagnetic force basically are the photons. So what is if you know the mass of photon, you will easily calculate their range, because h cut c is constant, only mass is variable. So if you know the mass of photons, you will know their range, but rest mass of photons is always 0. So putting the value of mass 0, so you will get your range infinite. What it means? It means electromagnetic forces have infinite range. Very important concept. Okay, let's move towards the second range of force, which is the weak force or strong force. So let us first discuss weak force. There are two weak forces like W plus minus and Z naught. These two are the weak forces due to weak interaction. Okay, the calculated mass of these forces are, you must know about this, like this is the calculated mass of these weak forces. This is nearly equals to, for W 80 gigaelectron volts, and for Z it is round about 90 gigaelectron volts. Okay, so this mass is for these weak forces. Now if you want to find the range, you just have to put the value of mass here, which is 8 gigaelectron volts. But for this, because the units of mass in gigaelectron volts per c square, so you also use the value of h cut c in gigaelectron volts units. So we know the value of h cut c in gigaelectron volts is 0.1975 gigaelectron volts femtometer. So this is the value of h cut c, and m value is 80 gigaelectron volts per c square, and this c square as remains. Okay, so now this c square cancels with this is c square, and this gigaelectron volt cancels with this gigaelectron volts. This divided by this, you will get this. And 1 femtometer is equals to 10 raised to power minus 15 meter. Understood? So after calculating, you will find your range, that is approximately equals to 10 raised to power minus 80. What it means? It means that weak forces have a range of 10 raised to power minus 15 minus 18 meters. Basically, this is the range of nucleus. The range of nucleus is 10 raised to power minus 15 are the nucleons range, and whole nucleus range is 10 raised to power minus 18 meters. So weak forces also have a range of 10 raised to power minus 18 meters. More than this range, you will not observe, you will not interact weak forces. So this is the range of weak forces. Similarly, we will calculate range for strong forces. Likewise, we take some examples for weak forces. You will again take some examples for strong forces. So let's take an example for strong force, which is Yukawa meson. Yukawa pi meson. Okay, so Yukawa pi meson is a strong force. It's a strong interaction. So the calculated mass of this pi meson is nearly equals to 140 mega electron volts per c square. But you know the value of H cut C is 0.1975 giga-electron volt femtometer. So you must have to convert this mass into giga-electron volt so that you will cancel units easily. So after converting mega-electron volts into giga-electron volts, you will get 3 points before 1, 2, 3. So you will get 0.14 giga-electron volts per c square. So this is your mass. Now putting the values of H cut C, mass, c square as remains, giga electron cancels with this giga electron volt, c square cancels with this c square, only you will get with femtometer. After dividing this and multiply by femtometer, you will get your answer this, and you only need this, which is the approximate range. So strong force have a range of 10 raised to power minus 15 meter. As I told you before, strong force is always between the nucleons, and you know the nucleons range is also 10 raised to power minus 15, which is femtometer. So this is the range of strong force, this is the range of weak force. And before we calculated the strong force, we calculated the electromagnetic force range, which is equals to infinite. Okay, so that's all for the four forces. Now we will move on towards the Feynman diagram. In Feynman diagram, we will just discuss some notations first. Okay, some notations like, first of all, you know what is Feynman diagram? A graphical way of display of interaction between particles and fields. Means in Feynman diagram, you will have to display a graphical representation of interactions. Whose interactions? Interaction between particles and fields. So there are some interaction between some particles and fields, and you have to just display them graphically. This is called Feynman diagram. Okay, sorry. Okay, so some notations for Feynman diagram. Let us know who's that. First of all, solid lines, straight lines. This type of lines in Feynman diagram denotes you for leptons and quarks. If there is this type of line inside your Feynman diagram, you will denote like that this is leptons and quarks. So if wavy this type of shape, this type of lines, then you can say these are photons. And you know photons are weak interaction. So there is weak interaction, weak means weak force. Wz minus z naught, this is weak force. So where there is this type of wavy lines, you will know there are weak force, and there are, this is for weak force, this type of line full crust and trough, and some type of this like high amplitude, low amplitude, this type of wavy line you will get, you can weak force. And for curve wavy lines, you will know that this is for photons. Okay, curly lines, which indicates, curly line indicates that they are gluons, and broken lines indicates they are bosons. Okay, similarly, arrow on line, if there is arrow, this type of arrow on lines, what this tells about basically time scale. Okay, direction of fermions flow, you can also say this. Also arrowhead on line denotes that the direction of fermions flow. Okay, where your fermion flow is going on. And there is also some vertices, you also know graph must have their vertices. So points where fermions and bosons meets. So the point where your fermion or boson meets each other, these points are basically the vertices. Vertices are the points where your fermions or bosons meet. Okay, this is the actual point. Moreover, strength of interaction, there is coupling constant. You will also take coupling constant, that is alpha electromagnetic EM. Okay, there are also some lines that are entering or exiting. Okay, some lines which are entering or exiting, but this indicates real or free particle while joining vertex for one virtual particle. Understood? That's all. The next thing which is very important, that you have to find the electric potential energy between Next thing, you have to find the electric potential energy between proton and electron. So electric potential energy, so we know that potential energy by the Coulomb's formula, we know that proton and neutron are due to opposite charges, they are attractive forces, so there must be negative sign which is meant by attractive force between proton and neutron. So the formula of potential by Coulomb's force is E squared by 4 pi epsilon naught r. 1 by 4 pi epsilon naught, you know this is the constant which is equals to 9 into 10 raised to power 9, and r is the between separation between, okay, between proton and electron, or either the particles you have, and this is the charge on the particles, okay. So let us take this, and we are taking the separation of atom, which is 10 raised to power minus 10, you know, which is 1 angstrom. So if you want to find the electric potential energy between proton and neutron, so these are attractive, so that's why we are taking minus sign here. So what is the charge on proton and electron? Charge must be same, which is 1.602 into 10 raised to power minus 19. So charge into a charge square means charge square multiplied by 1 by 4 pi epsilon naught, which is equal to 9 into 10 raised to power 9, 9 into 10 raised to power 9 divided by r, which is the separation. We are taking 10 raised to power minus 10 meters. So the unit of K is joule meter per c square, and the unit of charge is coulomb. So coulomb square means, for charge square means coulomb square, and here, so this meters cancels with this meter, this c square cancels with this c square. You will only left with joules. Then you have to convert that joules into EV. So to convert joule into EV, you just have to divide your answer with 1.6 into 10 raised to power minus 19. The answer of this, after dividing this answer by this, you will get this potential in electron volts, and this minus sign indicates that there is attractive, means proton and electrons shows attractive behavior because of opposite charges. Similarly, if we have to say that find the electric potential energy between proton and proton, so the only difference is between, because these are protons are nucleons, so you will just take your separation r, then 10 raised to power minus 15 meters. Okay, the charge is same on proton, means this square multiplied by 9 into 10 raised to power 9 joule meter per c square. Only the difference is if you are find proton, then 10 raised to power minus 15 here. After calculating, you will get your answer in joules, and after you have to convert your joules into EV. So let us find for proton. Here you can see that I find for proton and proton. So the potential, why I am taking positive, because you know proton always shows repulsive behavior. For repulsive behavior, we always take positive sign. So the charge is same, charge square means charge square coulomb square 9 10 raised to power 9. The constant joule meter per c square is the unit of that constant, and the separation between proton we are taking because these are nucleons, so 10 raised to power minus 15 meter. Understood? After calculating, you will get your answer into joules. After you have to convert joule into EV. Just have to divide it by 1.6 into 10 raised to power minus 19. You will get this answer in electron volts. Okay, so this is your Coulomb potential between proton and proton. We find before the Coulomb potential between electron and proton. Similarly, now if you have to find the gravitational potential energy between, before you are finding electric potential energy, but now if you have to find gravitational potential energy, so gravitational potential energy is find it by this formula: potential gravitational equals to minus g mass of proton square divided by r, where g is the gravitational constant, you know, 6.672 into 10 raised to minus 11 Newton meter square per kg square, and mp square is the mass of proton, which is, you know, 1.67 into 10 raised to minus 27 kg. By taking the value of r, the separation, if you are finding between protons, so you will take 10 raised to minus 15. If you are finding for either other thing like some atoms, so you will take 10 raised to minus 10. After putting the values in this formula, you will get your answer in joules. Then you have to convert it in EV. So this is your final answer of gravitational potential energy between protons, which is equals to minus 1.1 into 10 raised to minus 5 electron volts. Now, if you want to find the ratio between electromagnetic potential and gravitational potential, just you have to put the value of electromagnetic potential of proton, which is this, and gravitational potential between proton, which is this. So dividing this by this, you will get a range of which is equals to 10 raised to power minus 36. Understood? So this is your range. So if you want to find the gravitational energy, just take reciprocal, means this above, this downside. So you will again get your answer at the range of 10 raised to minus 36. Move this EM to the other side. So the final result is that gravitational potential energy is equals to 10 raised to power minus 36 times of electromagnetic potential. means that electromagnetic potential is 10 raised to power 36 times greater than the gravitational potential. So that's our final results.